After making the mesh in Ansys meshing, the next step is to solve this case in Fluent. And for that, I will duplicate this Fluent cell. And is asking that should upstream connection from the rest of the project be kept for created system? So no, because I don't want to create a connection between this Fluent setup with the old geometry and the mesh, as I want to create the new connections from the new mesh and the new model, and simply drop the mesh on the setup and right click on the mesh and also update this mesh file. So there are maybe some unfinished process in the mesh, so they will be done perfectly. And after that, click on setup, and this will read the new mesh file into the old Fluent, and this will keep all settings, which like for example boundary condition, everything will be kept there, and just the mesh will be changed. This is the benefit of working inside the workbench, that if you from the set, if you apply any change, so this will keep the all other things same, and this will only change that thing. But if you read the mesh file in the Fluent in the standard mode, so you have to make everything from scratch. So it is asking for some missing zones here, and to solve this issue you have to go to the file menu and click on recorded mesh operations, and then click on the mesh zone names. So because in the previous case we had there was a symmetry and the solid zones, so these zones are missing from the new mesh file, and in the new mesh file we don't have any symmetry condition, so just overlook this condition here and replace this zone which is a solid with the geometry 9 solid, and click on apply. So do you want to reload the setup? Yes. And this will simply replace the old name with a new name, which is now, because we have the new mesh file here, and it will have the new mesh, the new name for the zones. And since we don't have any symmetry condition, so don't select that condition here. And after doing this thing, this will be the error free or the warning free. And simply close this panel now, and you will see that all the boundary conditions, the turbulence model, they will be same there. And the only difference that in the previous model we had the symmetry condition, and here we don't have any symmetry conditions. So now go to the run calculations and click on calculate. So all other things are there, like boundary conditions, like the turbulence model, like the material properties, they all are same there. The only change here we have that now we have the new mesh file because the model is full here, and now just let this process to solve this case for a number of iterations, and once done, then I will come back here and I will read these two files, the half model which is already solved and the new file which is a full model, and again I will create a new connection for the CFD post, and I will couple these two files into the one CFD post, and we'll compare some results there. And as you can see that the now results, they are not changing much here, and also the monitor points, they are also now straight lines, or maybe there are some variation and they will continue to be there. So I think the number of iterations are now enough to post the results, and therefore I'm going to stop solution here. And then I will go back to the workbench, and since we want to compare, so I'm going to make a duplicate for the results, and I don't want to connect them with the upstream data of the previous cases, and simply move this cell on the location here, and now from solution cell on the Fluent, just drop this on the results. And also I will make the connection from the solution in the half model case. So this is a cell I want to drop here as well, and double click here, this will open CFD post, and you can see that now here the message is starting CFD post. Just wait for the CFD post to be started. and then here we will compare the results for the half model and as well as the full model. Okay, so now we have the two cases with us. So I will rearrange these views as the two windows only. And so also you can see that we have the copy of half model. So this is basically the full model. And to make correction for this, I'm going to again go back to the workbench here. And I will delete this connection first. And after that, I'm going to rename this file as full model new. And also I will rename this cell as the full model results versus half model. Okay, and now simply click this, hold this cell Z3 and drop this on the results. And if you open this now, you will see that now the name will be changed from the copy of model to the full model here. So just wait for this file to be loaded. And in this way, you can see now we have the full model new and the half model. And I can open only two windows here. And in the one, we have the half model. Second, we have the full model. And you can see that the results are not changing much here. And even if I display this model as a full model, this geometry, so you can see that they have the same results. And for that to work, we have the instance transform. And for that, I will just uncheck these options because I don't want to compare these two cases right now. So from insert, I'm going to insert this instance transform. And we want to make the number of graphical interface instances as let's say right now one. And I want to apply the reflection, and that is from plane, and that plane is right now is basically the XY plane. So from the XY plane, and Z is 0 and apply. So now we have this is enabled, so you can make the number of graphical instance as a 2. Okay, now just go to this file here. So we have this, like for example, it's a half model. So from here in the path lines, which is shown here, I can go there, and from the view you can click on the instead of the transform as a default transform, you can select the instance transform and apply. So I think we have some issue here. So I want to again revisit this instance transform. So we have that thing. Okay, so we have the apply rotation also enabled. So just uncheck this option and apply. Okay, so now you can see that we have the path line in the full model. So same as we have this model here. And also on the wireframe, I can choose the views, and again I can apply the instance transform here. So now you can see that we have this full model here. And now you can compare these two cases with each other. So you can see the results here. And they are almost similar. Okay, so the best option here would be that we can compare them based on the charts. And so you can see that we have a very little change on the velocity versus the curve length, and that is on the line 5. And you can see the line number 5 is over here, and that is if you take a look here, that there is a 90 degrees line here. And the second line we have here is on the somehow the upper height, and if you compare here as well, so you can choose the line number 4, and you can see that the results also again they are same. So as far as the line number 4 is concerned, which is same, and for line number 5 they are also same. And if you compare, like right now this is the temperature, if you compare the velocity, you can see that they are also same. There's little change here, but that change is not noticeable here. And if you go back here and if you take a look on the line number 5, you can see again they are same. So it means that for the simple case, if we don't introduce any turbulence or any 3D flow which can skew the solution on the one side of the geometry case, in this case we can apply the symmetry model, and symmetry model will give you same result as a full model. And it means that you can save the half sources in terms of memory, CPU, if you apply symmetry condition, and this is why we always prefer for symmetry model or for the periodic conditions. So now this is one aspect of this study in this case. The next case is that we are going to introduce solar in the small pipe. This will introduce turbulence and the more mixing.